Hello, welcome to this short presentation on the neurotransmitter GABA, why the combination of Valium and alcohol can be deadly, and how chloride affects muscle excitability. Gamma-aminobutyric acid, or GABA for short, is the major inhibitory neurotransmitter in the central nervous system, and 20 to 50% of synapses in the brain release GABA, so it plays a really significant role in the central nervous system. We can think of GABA's inhibitory message as a stop sign in the body because it reduces the activity of our cells. Knowing this, you can imagine that if the body's production of GABA was high, there would be a tendency to feel very sleepy and unmotivated. And if GABA was low, a high anxiety state would be experienced. So let's take a closer look at how this neurotransmitter interacts to cause an inhibitory response of a cell. Looking towards the middle of the graph at the peak, we can see that an action potential is the electrical change to a cell membrane that causes depolarization of the cell, which just means that there's been enough positive electrical change through the movement of ions to reach threshold, which then propagates a message along the axon of a neuron to another cell. Most importantly, this requires a positive or excitatory stimulus. But GABA, being inhibitory, has the opposite effect. On the far left, we have GABA being released from a presynaptic neuron and received by receptors on a postsynaptic cell. It does this by binding to a site on the GABA-A receptor, which opens a ligand or chemical gated channel, allowing the negative charged chloride ion to flow into the cell, making it more negative. Looking back towards the graph, we can see that if we have a lot of inhibitory signals, the membrane of a cell is less likely to reach threshold to produce an action potential. We can think of our cell's messages as backseat drivers, one yelling go, 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 and someone else yelling stop, stop, stop. But what would happen if your neurons only got the message to stop? The GABA-A receptor has a binding site for other chemicals as well as GABA, and they all open the chemical gate to let chloride into the cell. So because they cause the same inhibitory response in the central nervous system as GABA, they just do it in more potent ways. Valium is a psychoactive drug from the benzodiazepine family and is known to have a relaxing and sedative effect, and alcohol we all know affects motor coordination. The interesting thing is that GABA-A receptor has separate binding sites for all these chemicals. That means that they are not competing for the same site, but can all bind at the same time and combine their effects. We can see the benzo binding site, two GABA binding sites, and an ethanol binding site. Imagine the inhibitory effect of the central nervous system when the combined effect of these drugs are bound to many receptors, all sending the message to stop. First, the respiratory system would slow down, then the cardiovascular system. Basically, no action potential means no muscle contraction. That means no movement or contraction of smooth cardiac or skeletal muscle. As more and more of the neurons are bound by benzos and ethanol, the central nervous system eventually shuts down. So we've seen the important role chloride plays in changing the electrical charge of a cell membrane. Now let's look at its effects on the skeletal muscle. Chloride is actually the most abundant anion in the body, and we have seen the body use its negative charge to help make cells more negative and slow down or stop activity. This is also true in skeletal muscle, but it just works in a different way. Chloride enters the muscle cell from the extracellular fluid via channels that open with the depolarization of an action potential. Within the cell, it assists to reset membrane excitability and ensure electrical stability of the muscle. This helps with muscle relaxation, and chloride has been shown to play a role in muscle fatigue. But what happens if something goes wrong with the protein channel that allows chloride entry into the muscle cell? The chloride channel CLC1 can experience a mutation in the protein sequence that causes it to remain closed. This channelopathy causes hyperexcitability and an unstable electrical membrane of the muscle cell. So in this case, we have an action potential that causes a muscle to contract, but without chloride, the cell is unable to effectively reduce its excitability and may spasm. The muscle is also unable to relax and stays stiff after muscle contraction. Overall, chloride plays a vital role in the physiological function of the body. Thank you. I hope you enjoyed this presentation.